Okay, so one more time, good morning to you everyone. So let's get started. Shrini, thanks for joining. So Teja, thanks for joining. Vivek, everyone, good morning. So let's get started on this journey, exciting journey. Okay. So I welcome you all one more time to this program. So we're going to call this Big Data Hadoop Developer Training Program. So I will be your instructor as well as the coach, friend, and it's going to be a collective journey for all of us together. So please treat me just like your colleague, and feel free to ask any kind of questions. There's nothing in the world that I'll guarantee that I'll have answer for everything, but what I can guarantee for you is that I will go through, do the research also if needed, and then get back to you on the questions that are not being answered. Okay, so learning experience matters. So I want to really set the mood here. It's very important to understand this. The ambience is very, very important, right? So please kindly choose a isolated, undisturbed place. I know it is difficult to find such place in nowadays, but still, since it's early mornings, so please kindly see that you find a place where you could exclusively focus on the learning. So don't do this in a hallway, or don't do this in a place where kids are around. I mean, if the situation demands you to be in that, that's fine, but ideally please try to see that you are committed to get the maximum benefit out of this experience. So please make sure that you're doing this in your office room or somewhere like that. Also, one of the other important thing is I personally prefer having headphones. Helps a lot. So please see if you can have headphones if you are in the public area, or if you are in a place where there is a lot of motion, commotion and all. Feel free to have the headphones also. Most important thing is plenty of water beside you, because the more you drink water, the better the neurons in our brain work very well. So one of the things that nowadays I'm trying to follow is have a bottled water, or some kind of a have water beside you basically. And we will also have frequent, not too frequent, but we will have at least 1 or 2 breaks in the 3-hour class. We'll try to make it as engaging as possible. And anytime if you have any questions, you have 2 options. One, you could use the chat window to directly type in your question. There is a specific reason why I deliberately actually muted most of you, every one of you. The reason being, in the past, keeping the line open, and sometimes people forget, they are sometimes traveling, and I'm not saying that everyone does it, but it creates a sort of a disturbance for the rest of us. So to have a very seamless, good experience of the overall learning process, I am muting you all. But having said that, if you have any questions, please use the chat window to type in the questions. Or if the situation demands, I am willing to even open the line, and you can actually talk, and we can have a discussion too. So just mention that you have a question that you want to speak out, then I'll be able to unmute you selectively and then do that. Okay, so are you guys all excited? I want to know if you're all excited to hop onto this journey of learning. I need please give me yes. Oh, thank you, N Vidris, I think your name. I'm sorry if I'm mispronouncing. Thanks, Hemant, for that. Gautam, thank you so much for the confirmation. Oh, okay, Murali. Oh, okay, you're Murali. I'm sorry, Murali. Yeah. Teja, thanks for the confirmation. Vivek, thank you so much. So perfect. So this is going to be a very exciting journey. Some of these complex concepts that we're going to talk about would be slightly complex, but we'll break them down in such a way that it's easy to understand. Understanding the concepts is one aspect, but putting those concepts to practice is the most important aspect. In the training class, I will be showing you guys all the hands-on exercises and how to do them. But at the end of the day, it is you who is going to choose to do those exercises on time. So please understand that. So the commitment from your side that you will do this is in your hands. So please kindly make sure that you do the hands-on exercises and any assignments that we identify during the course. So please make sure that you do that. So everyone, please, not that you're giving a commitment here, but you're giving a commitment to yourself. So please say that I will stay committed to be on this training for until the end, including myself. I'm going to type to everyone saying I will stay, I will try my best. Practicalities are practicalities, but from our side we should have that commitment. So I will stay committed to be on this training till the end. So I typed the message to you all. So please say that I will stay committed. It's a way of enforcing, and you're doing it for yourself. It's very important. Thank you, Vivek, for sending that positive vibe. Thanks, Teja. Thanks, Gautam. Till the end. Wow, amazing. Yeah, perfect. This is the kind of spirit that we need. The road is going to be not always smooth. It's going to be challenges, but at least we want to stay committed. Yeah, thank you, Shrini, for good morning, by the way. So, Shrini, I think you got your machines also set up, right? So that's good point. Yesterday, perfect, Shrini. Wonderful. So let's stay committed together. As I discussed in the class 0, there will be challenges, but we will go through them. Okay. So we also discussed about the plan B then, right? But forget about plan B and A. So from our perspective, staying committed is important. So what that means for us, for all of us, including myself, is we come to the class on time. We do the hands-on exercises, not just theory. And once you're done with the theory, so please take time to do the hands-on exercises and please do the assignments. And there I will also be identifying some resources as an extra study thing that you could do. So anything that we need to do, most important of all the things is hands-on. Get your fingers to the computer and then do the hands-on exercises. That's most critical. Generally we tend to listen and everything, and slowly the spirit will go off, but we want to make sure that we are going to do this for ourselves. That's why the way this time we are doing this is like in a slightly rapid fire kind of a fashion. So we have today is November 1st. The idea is that in next 19 days we're going to finish the whole thing. There is a lot of things that are there, so you would need to do your groundwork also every day. So please make sure that you do committed. The most important commitment here is to do the hands-on exercises, and I'm sure that you will have challenges there. So I will be going forward. What I'm going to do is, after the class is done, we will take a half an hour break, and then I'll stick around, and we will have you guys do the hands-on exercise also. Another thing is, I will choose some of you during the course of time to present what you're doing also. So rather than so I will randomly choose, and I'll ask you, and please don't mistake me. I'm not going to put you on the spot. If you don't feel comfortable, you can always deny it in the chat window saying, hey, whatever the situation I'm in right now, I can't do it. You can always do that, but ideally please be prepared to share your desktop. So the other day Murali shared his desktop and shown every one of us how he could actually had the entire virtual machine up and running. So I would do the same thing randomly. So can you all please confirm in the chat window that your Cloudera's virtual machine is now healthy and up and running? Say up and running in the chat window, please. It need not be up and running right now physically. What I meant is you could do that, Yeah, perfect, Hemant. Perfect, Ashish. Thanks, Gautam, for the confirmation. Let's do a quick roll call here. Ashish got it. Teja, perfect. Everything is set up. Perfect. So, did anybody ran into the error that Hemant shared with us in the document? Yes. Okay. Were you guys be able to solve it? So last time when we did it, okay, let me go to that document in class 0. Where is it? Okay. So Hemant had this issue while starting the virtual machine. I don't know if you guys can see it. Let me zoom in a little bit. So this issue came, right? So did anybody face this one? Srini faced it. Srini, were you able to solve it? Who else? No, still there. Oh, so then that means you still have to get that thing up and running. So you please refer to this document. Okay, you have the videos also there. You just go into the BIOS. So just go into your BIOS settings, and there will be something called virtualization flag. So you would need to enable that. Enable the virtualization. So these two videos, this is a hardly like a 30-second video. So actually go ahead and watch that, and or go into the detailed one, and please make sure that you have that up and running by today. Okay, so for those of you, so let's go back to our today's handbook. One of the things to do today, so today is your last chance to do this. Make sure have your Cloudera virtual machine up and running today. So solve any problems that you have, please, everyone. Okay, so because from tomorrow onwards we'll be doing more hands-on. So today will be just the concepts. Tomorrow we will be doing a lot of hands-on. So please be ready with your virtual machine up and running. Maybe we can spend right after the class, we'll spend about 30 minutes or so to make sure that if you have any questions or anything around that, we can also solve that. Perfect. So Ashish got it. Gautam, did you get yours up and running? So it's running, right? Yeah. Okay. Very good. Hemant, I know for sure he already resolved it. Murali was already had it. Srini is also working on it. Teja, you got yours up and running? Perfect, Teja. I know Venkat already had it up and running. So Vivek. Perfect. So that's good. Amazing. Very nice. Great going. So that itself is a positive vibe there. So let's get started on this. So the agenda for today is we'll discuss what is big data, what is the definition of big data. We will let me make sure that I can zoom this here so that you guys get a very good view of it. Okay. So we will discuss about distributed systems and challenges around distributed systems. We will then discuss about what is Hadoop, right? And we'll talk about the concept of structured data and unstructured data. We'll look into Hadoop history. We'll do the Hadoop's ecosystem details. Then we'll discuss about the use cases and the architecture. So that's the path we have set for ourselves today. Okay. So during the course, I'll be updating this handout, and as soon as the class is done, you will have by the end of today, you will have the video recording, and within half an hour, you will have the this handbook that we are preparing during the class. Okay. So also please make sure if you can run this in full screen mode. That will also help a lot. Just a second. Yeah. So make sure if you could run this in full screen mode, then you'll have good real estate on your screen to be able to observe things that are happening on the screen. Okay. Oops. Okay. Okay. Like I mentioned, commitment is expressed in regular attendance, doing your homework, and taking that exclusive time off for learning. Taking that whatever the time, just even what I've seen is even small buckets of 30 minutes a day, not a day, I mean 30 minutes, like in 2 or 3 cycles like that in a day. 1 hour is enough. If you do 30 minutes in the morning and 30 minutes in the evening, just to refreshing on things and doing some quick hands-on, you will always be up to date. Okay, so please have at least that 30 minutes, 1 hour window minimum. I'm not saying that you have to have I'm not saying you can't do more. You can do, if you can, if your time permits, if your lifestyle permits, please go ahead and do for more hands-on too, but at least stay committed to do 30 minutes of hands-on. So just like the way you take exclusive time for learning, you should also make sure the fun activities, like having that quick walk with your spouse, or playing with your kids, all those things also matter actually in the learning process. We think that the learning process starts in the classroom and ends in the classroom. No, it's not. It is beyond. It goes beyond also. So having that good breaks and having a good balance makes sure it ensures that our neurons are rightly fired to get more knowledge and experience. So like I said, start on time, break time is break time. So this is also I want to emphasize here. When I give a break time in the class, please kindly make sure that you really literally take that as a break time, not that you will take you will browse on other websites or catch up on latest news. No, when we give a break time, we usually do 10 to 15 minutes of break times. During that time, literally get up from your place wherever you're doing this and go elsewhere, have some quick chat with your friends or whatever, and then take a walk or whatever, and then come back within that time, whatever the time we all agree on. Okay, so don't stay at the computer, do something else. That's what I mean. So break time is break time. Question and answers, like I said, 2 options: chat window. If not chat window, then you can also open up the line itself, phone, audio itself, or microphone. So I can do any of them, so let me know. Okay, so any questions on this so far in general? So I take it as no. Okay, so we'll move forward. Okay, so introduction to Hadoop. Right, and please pay attention to a quote here I have here. It says, in pioneer days they used oxen for heavy pulling, and when one ox could not budge a log, they didn't try to grow a larger ox. We shouldn't be trying for bigger computers, but for more systems of computers. Okay, let's say you have a computer with whatever the resources. Let's say a CPU of 2 GB, the RAM of 2 GB, a hard disk of maybe 100 GB, a processor with a clock speed of whatever 1 or 2.4 gigahertz, quad core or dual core, right? So you have a processor, you have the brain of the computer, which is the random access memory, and the hard disk of the these resources. So you have a computer, let's say. Now if you want to do more tasks on it, rather than increasing the specs, the natural tendency is that we increase the spec from 2 GB to 4 GB. Maybe replace the motherboard with the processor with a quadruplex core, or quadruple core, or 8 core, octo core, whatever, right? So you can increase the specs like this, or you could expand in a horizontal way. Instead of one server with the same server, if I want to do more work, I could have multiple servers that are doing simultaneously, sharing that workload. So you can do the same thing. So what Grace Hopper, one of the is also one of the defense US military guy, and also a computer architect by himself. So he says that we shouldn't be trying for bigger computers. Don't try to increase the specs of your bigger computer, but for more systems of computers, rather expand horizontally. Okay, you understand this? Expanding vertically means increasing the specs of your server. If you have 2 GB of RAM, maybe you will get go to bestbuy.com or wherever and buy another one that has 8 GB RAM. You go replace your motherboard and then replace the, let's say, i5 processor with an i7 processor. Replace the hard disk that you already have, 100 GB one, with a SSD, maybe 1 TB SSD. So that's called increasing the spec of the same computer. So I'm calling with the notion that's called vertically. The specific term we will use is, I will use that in the subsequent slides. I want to refrain not to use that for now. So you basically expand vertically, but rather what Grace Hopper is saying is, don't do that. Rather, have the same exact old computer, make multiple copies of that and have them in tandem work together to do the same work. So that's called horizontally expanding. Okay, everyone understands what I meant by vertically expanding and horizontally expanding? Simple. You have a computer resources, increasing the same computer resources, the specs of each one of them is vertically expanding. Horizontally is basically, instead of one computer, you will have 5 or 4 computers working together in tandem to do the same workload. That's called horizontally expanding. Is that simple concept clear? Thanks, Teja, for the confirmation. Thanks, Hemant. Yeah, we will expand on this concept. So this is the theme for the Hadoop. Remember this as a theme for the Hadoop. Okay. Perfect. Thanks, Shrini, for confirmation. So we'll define what the problem is, what the Hadoop system actually addresses, and then we will discuss about the Hadoop entry of Hadoop and the ecosystem and the architecture. So what is big data? So we live in the data age right now. It's not easy to measure the total volume of data stored electronically. And IDC, the company, is like a Gartner company. Okay, wonderful. Hemant is asking an interesting question. Will that be cost effective? Yes, cost. We will get to that, Hemant. So hold on to that. That's a very good thought. So you already started thinking about, what if I have multiple computers? Would that be really cost effective? That's a very nice question. So we'll get on to that, Hemant. Okay. Because that is one of the main features of Hadoop. Why this Hadoop all of a sudden became a huge, rave in the industry is one of the aspect is that it's going to be cost effective. We'll see how that is. Okay, Hemant. We'll get on to that. So what we're talking is, we are living in a data age, and we know that how much of data is being stored across the world right now on the internet is unlimited. And IDC, one of the analysis company, the marketing and research and analysis company, right? They are saying that there is a digital universe out there with about roughly 0.1 zettabytes, and this was expected in 2006 itself, and they were expecting in 2011 they already recorded about 1.8 zettabytes. Now, by the way, if you're wondering what a zettabyte is, 1 ZB is let's start from the basic otherwise, right? 1 zettabyte is equal to roughly 1024. So let's, for the discussion sake, we will call it as just 1000. Okay, it's actually technically speaking 1024. Okay, so 1 zettabyte is roughly equal to 1000 exabytes. So usually you denote that with EB, right? So let's write this down here. 1 ZB. Okay, let me erase everything. Let's do this. 1 ZB is equal to 1000 EBs, exabytes. And 1 exabyte is again 1000 petabytes. So let's say 1000 comma 3 zeros again petabytes. So 1 petabyte is equal to 1000 terabytes, TBs. Remember those hard disks that we are buying in Costco or wherever, 3 TB, 4 TB. 1000 such TBs, terabytes is equal to 1 petabyte. So I'm going to have 1, 2, 3, 1, 2, 3, 1, 2, 3. So total terabytes means 10 to the power of 9. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's, in other words, 1 terabyte is equal to 1000 TB is equal to 1 TB is equal to 1000 gigabytes, GB, right? So if you see 10 to the power of 12 gigabytes. So in 2011 they have already recorded 1.8 zettabytes of data in the digital universe. So you can imagine now this is what this was in 2011. Now we are in 2014. So with the advent of lot of digital devices that are out there, we can understand how much of data is increasing, exponentially increasing now, right? So this flood of data is coming from many sources. New York Stock Exchange records, and this was again recorded in 2011 itself, 1 terabyte of data every day, the transactions that are happening. Facebook today hosts about 10 billion photos and 1 petabyte of storage, means basically Facebook has 500 terabytes per day. Okay, so 500 TB is how many petabytes? 1 petabyte is equal to 1000 terabytes. Just remember that. So 500 terabytes means half, half of it means 0.5 terabyte in 1 day, means in 2 days. In 2 days they are recording 1 petabyte. Just in 2 days. That means in 1 month they will record how much? Can anybody say how much? How many petabytes? Srini, Ashish, everybody says 15 petabytes. Perfect. Yes. In 30 days they are recording 15 petabytes of data. So if you do the math for 1 year, means multiplied by 12 roughly. So 15 multiplied by 12 is how much? Two 5s are 10, 2 1s are 2, 5 1. Is that correct? 180? Yeah, correct, you're right, 180. So 180 petabytes in 1 year. Just in 1 year, Facebook is generating so much of data. So you can imagine how much of data is coming. 500 terabytes multiplied by, yeah, exactly, 182.5 petabytes of data is coming in 360. So I did the other way around. Instead of doing for 1 month and multiplying by 12, I did 500 terabytes multiplied by 365 days. So roughly 182.5 petabytes of data is being created at Facebook every single day. So Ancestry.com, the genealogy site, stores about 2.5 petabytes of data every day. No, not every day. I'm sorry. It stores the overall volume of the data. Okay. So the Internet Archive stores around, the archive store, right? Archive.org. I think it stores about around 2 petabytes of data and is growing at the rate of 20 terabytes, 20 TB per month. the Large Hadron Collider near Geneva in Switzerland, it produces about 15 petabytes of data per year. This is Large Hadron. So this is an underwater thing, but I think it collects a lot of data, and then it produces about 15 petabytes of data per year. So there is a lot of data out there. The point here is there is a lot of data out there, but you're probably excuse me, I'm sorry. Yeah. So just a second, please. Okay, yeah. So you may be wondering then, hey, so there's so much of data out there, so how does it matter to me? Most of the data is usually locked up into these search engines or these financial institutions or health organizations or scientific institutions. So this whole term called big data, as it is being called right now, how does it affect companies? I'm not Facebook. I'm not a New York Stock Exchange. I'm just one single little guy living somewhere, and I have my. How does it's going to affect me? You may think like that. Or I may be running a smaller company, a smaller organization. How would it impact me? So you may be thinking like that, but the answer is it does affect. It's already affecting us if you really pay close attention to our own lifestyles. Let's take an example of taking photographs. If you go back, flashback to like about 10 years back, we used to happily take those photos using regular photographs camera, go to Walgreens or Costco or wherever, go print them out and then come home. After the digital cameras came, now every one of us know how difficult it's becoming to just manage and archive and store them and see them when we want to really see them, right? How many of you agree? You may be doing some good job around archiving and categorizing them very nicely, but majority of us, at least I'm having challenge to maintain them, copy them, not to lose them, archive them, and then also access them when I want to. Are you not feeling at the personal level itself you are having problem now? Yeah, because the data, the amount of data, with the videos and all those things that I am collecting, I myself realized, and I actually did an estimation of how much the data is increasing on my own end, and all the 3 TB drives that I had are already gone now. So I'm looking at at the rate of at least 500 GB, half a TB per year, even if you say, which is now no more the case. In my case, I'm almost seeing almost close to 750 GB per year. So 750 GB per year means in 1 year itself it's 1.5 TB. That means if I get a 3 TB worth of this one, I can probably I should always have 50% only, right? So if I get a 3 TB of disk space, I can sustain it for maybe 1.5 to 2 years. That's all. So that's the rate at which the data is increasing, even at the personal level. So what to speak of doing this at the business level, even a small business or medium business. And what forget about the companies like Facebook, LinkedIn and all that. That's the largest amount of data. So if I am filling in about 500 GB, even if I say 500 GB of data compared to 10 GB in 2007, that's about like 45 times speedier with which my data is increasing in the last 6 to 7 years. So you can imagine how much it's going to affect us. Okay, so no one can deny the fact that data is increasing. That's a given fact. Perhaps more important thing that every one of us should really think about is that the amount of data generated by the machines will be even greater than the data that is generated by the people. Okay, important here, please understand. The machines are generating even more data than humans. All these machine logs, RFID readers, sensor networks, GPS, vehicle GPS traces, retail transactions, web logs, all these things contribute to the growing amount of data. Right? You have the RFID readers here, GPS sensors here, sensor data. This is, I think, GPS tracking. This is a web log. So much of data is coming across all the places. The volume of data being made publicly available is also increasing every year. So now, if you go to Amazon S3, they are hosting a lot of huge big data on the cloud itself now. You can actually, shared archives of the data is available for us to access that on the Amazon cloud. So organizations are no longer thinking in terms of merely managing their own data. Success for these organizations, the return of investments for these organizations, actually in future will be dictated by the large extent by the amount of data that's out there also. So they have to, in order to drive their businesses, they have to be prepared to handle the data, to analyze the data, to get the insights insights into the data, and then extract those insights and then apply that to their business models. In order for them to stay competitive, they have to do this. Even initiatives such as public data sets on Amazon Web Services or infochimps.org or theinfo.org, they all exist only to foster the idea that so they are coming with this concept called information commons. I'm writing it in simple words here, information commons. Information commons means the notion that all these public data sets, I have my data that I have this business assets and data that I have with me, but the notion is that I am willing to share this with the rest of the world, and in exchange I will also collaborate with the companies and then take that data and then apply to my model. So that whole notion of information commons is a good initiative that's happening right now. So the practical application of that is the Amazon Web Services or infochimps.org or theinfo.org. All these companies are doing that, where the idea is that the data can be freely or even for a modest price. Amazon Web Services, they charge price, but it depends on the amount of usage of the time. So either freely or for a modest price, the notion is that this data can be shared for anyone to download and analyze. Okay, so that's what is happening right now. So the big data is of high relevance now. Right? So what is big data? Let's look at the Gartner's definition. Big data is a high volume, high velocity, and high variety information assets that demand cost-effective, innovative forms of information processing for enhanced insight and decision making. So there are a couple of things. So please pay attention here. This looks, in the beginning, it looks very, little, jargonish. But let's dissect this. Okay, I'm gonna go into this mode. Okay, just give me a second. I am on the slide. What was the number of the slide? 13. Okay. So let's do this. Let me erase everything here. Okay. What is big data? Big data is high volume, high velocity and high variety. Let's write that down. Big data is high volume. What is next? High velocity. And high variety. So let's dissect that first. Okay. High volume. High volume means what? Volume means the amount of information, the quantum of information that is being talked about here. So actually there is, if you go to the of course you'll get these notes. So in the reading references I have here, there is this nice IBM's infographic that I want to share with you all. Let me open that. Okay. Okay, can you all see this? So let's zoom in here a little bit. Oops. Okay, high volume. Yeah. Let me see if I can unzoom a little bit. Okay. Okay, there you go. So they are saying high volume means simply 40 zettabytes of data, 43 trillion gigabytes. 43 trillion gigabytes will be created in 2020, an increase of 300 times from 2005. So you can imagine how much of data is being generated. That's called high volume. So the big data can be classified with these characteristics, four V's. It used to be 3 V's. I think they refreshed this now to 4 V's now. So let's see what those 4 V's are. Okay. 40 zettabytes of data. Volume is the first thing. 6 billion people have active cell phones. And world population is 7 billion. If the world population is 7 billion, 6 billion people will have cell phones. So you can imagine in 2020, this is all vision 2020. By 2020, 6 billion people will have phones. 2.5 quintillion bytes of data is being generated on the internet each day. Right? Most of the companies in US have at least 100 TB of data stored. Most of the companies, even a small company, even if you're running a small restaurant, side restaurant, you will end up creating 100 TB of data. Whatever the data, customer data, transactions data, right? Everything. Next thing is variety. What do we have in our this one? Let's go back here. High velocity. So let's talk about velocity first. Right? The high velocity is, velocity means what? The speed at which the data is being generated. Okay, the New York Stock Exchange captures 1 TB of trade information during each trading session. Almost like every day you get 1 TB. By 2016, it is projected that there will be 18.9 billion network connections, almost 2.5 connections per person on the earth. So LinkedIn, Facebook, all these things, right? They are expecting like that, 18.9 billion network connections. So velocity means simply the speed at which the data is increasing. Volume means the amount of data that is increasing. Velocity means the speed at which the data is increasing. Right? Modern cars have close to 100 sensors that monitors items such as fuel level and tire pressure. You already have sensors in the cars. Now this whole, one of the other emerging technologies that's happening is called Internet of Things. The idea is that it's so far the humans are interacting with the machines. But once you have the Internet of Things, the machines will communicate among themselves. So it's already there. Some of these concepts are already there out also. But look for Internet of Things, and it's going to drastically change how the technology will be adopted at a commercial level into our day-to-day lives in future. So you could be going on in your car, and control your car will control the temperature of your bedroom. So you can actually switch off the lights, and if the whole family goes to, if you're living in US, if you all go to a vacation to India, from India you can turn on the lights in the home right from India itself. So that in the night time you want to give a feel that somebody is always home and nobody tries to come to your home. You could do things like that. So that Internet of Things is going to come. So that means the data that it generates every time, forget about that. If you live in East Coast, you most likely know all this turnpike, New Jersey Turnpike, or Pennsylvania Turnpike. Every time you go, or even in Texas where I live, you have this, on the road. Every time you're driving, there's so many sensors that are out there that are collecting the data. Which exit, which entrance you entered into, which exit you entered into. So imagine thousands of cars that are going on the road. So much of data has been connected by these sensors. So the volume of data, the velocity of the data means how fastly it is increasing. So I'm going to leave this whole thing for you to read it. Okay, I'm going to quickly give you a synopsis here now in the interest of time. But one of your assignment today, hands-on, for those of you who have not done it, I have your Cloudera virtual machine up and running. And the second reading reference for you after the class is that you have to read this in detail. Okay, so please go into this infographic and then read that. And next thing I also have as an exercise is that go to this podcast and listen to this podcast. It's going to take about 15 minutes. Okay, let me write that down. It's a very interesting podcast that I came across recently. So please read this today after the class. Read this and listen to this. Okay, so that is called high volume, high velocity. Let's talk about high variety. Variety of data. As of 2011, the global size of the data in healthcare was estimated to be 150 exabytes or 161 billion gigabytes. Different forms of data. So you're getting different forms of data. You're getting the data in the form of raw files, in the form of unstructured data, in the the sensor data, things like graphics data, vector data, video data, right? JPEGs data, all kinds of unstructured data that is coming in the form of Facebook posts or tweets, email data, your structured RDBMS data in your database system. So data collected by wearables, wireless health monitors. Now you have Google Glass, you have Apple Watch is coming. So amount of data that it collects and shares. Now you have in the Apple now released a health kit. So the idea is that on any of your iOS device, using this health kit, it collects using the sensors, it collects the health related, your body related information, and then directly through WebMD or some kind of interfaces, if you register your doctor, it will directly send your doctor all the reports. If you have an urgent emergency, if you're driving and suddenly all of a sudden something happens, automatically the phone dials based on your information and situation, dials 911, and also the immediate it will let your doctor know about what is happening with you. So all those things are coming. So the amount of data, all these sensors, wearables, the variety of data that they are collecting is also wide range, right? 30 billion pieces of content, 4 million tweets, so much of video on YouTube, on Vimeo, so many, all these websites. So much of data is being collected. So variety is the third aspect. So let's go back to the Gartner's definition. Volume, velocity and variety. Volume, velocity and variety. High variety. Information assets. right? He's calling it as information assets. They're all assets, right? The more amount of information you have and the more ability you have to analyze that information, that becomes your asset. Typically, what are our assets? If somebody examine our assets, we think of, okay, I have an apartment in India, or I have a car that I'm driving here. Those are our assets. A computer, whatever, right? Whatever the assets we have. So similarly, for organizations, this huge data that is characterized by high volumes, high velocity, and high variety is an asset for them. Just storing the data is not an asset. You have to, the asset can be translated into its value only when you can reap the benefits out of it, right? Let's say you bought a latest Lamborghini car, sports car, right? So you bought a car and you keep it at home in a garage, lock it down, right? And then you never take that car out. What is the value of it? Unless you put it to use, only then you can reap the benefits of value, right? But if you open the garage door, drive it outside, and then whatever it is, value. For some people the value is that, hey, I'm driving the latest and greatest stuff on the road. For some people, mileage is the value. For some people, fitting as many people as they can into the car is a value. So different people have a perspective about what value they want to drive. So storing just storing the huge amounts of data on a disk is not of any value unless you can you treat that as an asset in order to drive value out of it. So Gartner says big data is high volume, high velocity, high variety of information assets that demand cost effective. Let's see what that demand cost effective. Now Hemant asked, hey, how is Hadoop is going to be cost effective? So we'll get to that aspect. Okay. So that demands cost effective, innovative. Okay, hang on to that idea, being innovative. Okay, innovative forms of information processing. Innovative forms of information processing. So you need your processing ability of data to be very innovative, right? It should be cost effective. It should be highly optimized and innovative way of processing the data. Okay, why is this coming like that? Processing. Okay, right? Innovative forms of information processing for enhanced insight. For enhanced insight. Let's say you go to your bank accounts on your web on the internet. Go to whatever, Bank of America or whatever, and run a report for the last 2 years. Then let's say you categorize that into where did I spend my you have to get that insights. How am I spending my money? Am I spending my money on electronic gadgets? Am I spending money on my groceries? Am I spending more money on mortgage and insurance? Am I spending? So you get insights of that. So Murali has a very quick comment here. Data is growing, but after few years, why do we need to process old data or even have them unless for archiving? So very nice. So we will address that also, Murali. So it's important that the more you the approach now the data scientists are taking is there is no more a criteria that I can apply and say, hey, this old data is no more of value for me. So they're moving away from that notion. I need my whole data. See, all this while especially the data management tools and systems that were being commercially being distributed, since they could not handle so much of data for my for my analysis, they were forced to archive the data. So we will get into that today. So we will be discussing about the use case especially one of the retail company that we will take as an example and understand what they did and what was their challenge. So the data scientists in general, the short answer, Murali, is that they are moving away from the notion of, in fact, it is not the data scientists, but it is because of the incapabilities of the existing data warehouse and management systems to handle so much of data that we are forced to archive the data. But no data you can say that is not eligible for analysis. Right? No data can be, you can never say that, it's depending upon your business model, we may think, but the data scientists are coming with more statistical models that take into consideration of all the 10 years of data. It was because of the processing systems that are not able to do that, hence I was forced to archive the data. And there are so many instances, if you see, especially those who have worked in this, in the storage administration, they know that very well. I had a friend of mine who worked in storage administration. So his day-to-day job is to maintain storage. He will allocate data for the databases. He will archive the data onto the tapes. He will put the tapes and go into the data center and put it in a confidential place. When somebody asks for the data, I ask, that he used to tell me a lot of times, when you want to reload the data for your analysis, the time itself it takes is roughly 1 week. So he has to go find the data in the tapes, take the tape, load it back, and then make it live, and then the analysis tools will hop onto the data and then do it. So the whole process will take about at least 7 days. So he used to tell me that. So that was a challenge. The businesses want to get a complete insight. The data scientist, the data science is now the hottest thing that's happening, because the power of keeping we are moving away from the notion of archiving and purging the data to keep it always live so that I can do my analysis irrespective of whatever the situation is. So they are moving into that direction now. So and you can apply all these profound statistical models and algorithms on the entire span of your data and then get more insights. For example, one of the retailer company, they found out that after doing analysis in their stores, they found that people who buy diapers, right? People who buy diapers every time, they found that majority of the people to have the propensity to buy even a beer along with it. Now, does it make sense for us? Guy who goes to buy a diaper is also buying a beer? It doesn't. But now if you go to that retail store, you can see how they strategically. So let's say that your data analysis comes and tells you that, hey, people who are buying people who are buying diapers are also buying beer. So now in the store, would you put them together side by side, or would you put them apart? What would you do if you know that your data scientist will come and say, hey, in your store, you know that now they are the people who are majority of the people who are buying diapers are also buying beers. How would you do that in your store? If you are running your business and if your data scientist tells you that, how would you do that? Everyone, please. Would you put the beer and the how would you place them geographically within the store? Where would you put the beer and the diapers? Very close to each other? What do you think? Hemant, Mallikarjun, Murali, Srini, Teja, everyone, please. Murali has a very funny thing. people will get beer wherever it is. That is true. If they want to get it, yes, they will get it. So you know that people will get it anyway. So now let's see from the diapers perspective. So we think that it's side by side, but they strategically put in such a way that they know that majority of the people will buy beer and beer anyway, and majority of the people who are coming for the diaper also will buy anyway. So they will put it strategically so that your path is put in such a way that less sold items are also on your way, so that it can attract your attention and pick another extra things while you geographically go around from diaper section to the beer section, wine section. So they are thinking like that, what if I put all the, what if I put the batteries just about where the checkout is, versus what if I move it to the section B. So they have the storehouse also, right? They have different sections, priority sections. They want to get the insights of what traditionally for the last 5 years I put my batteries in the less priority or section B of my geography so they usually calculate it from the exit point of view, where you do the billing, and they go all the way to the back. So they want to get insights. Where would if I put a specific item at a specific location, how is that being sold? So they are getting into new areas now. Even the campaigns, the marketing campaigns that they're running, like all the coupons that you get. I'm talking about mostly the retail use cases here. Let's say your company, whether it's a Target or whether it is Walgreens or whoever it is, they send these instant saving books. Every month you get Costco book. Every month you get Sam's Club book. Every month you get all these books, right? You go with these coupons. Now they are thinking, or they'll do email campaign. So you'll get in the email, you get a lot of these coupons. So they are going into the extent of what time, when would I send, at what time if I send this email, the propensity, the probability of opening that are high. The probability of my click rate is high. Right? So I want to analyze, if I send it in the early morning 6 a.m., the probability is high. If I send it in the evening, the probability is high. So they want to get into what time is opening, how many links are being opened, what is my click ratio. So all those things they want to analyze, and all these new ways of analyzing the data, these opportunities are opening up, and you can achieve more only if you have all of your data live, right? So you can no more this whole notion of purging the data is in fact is becoming a bottleneck now. My competition is doing it, so let me do that. Let me hire more data scientists. Let me get more academicians also onto the plate, and let them give their perspective. Let them explore my data and tell me what I have to do. So that's the new notion that's coming into place. Okay, so volume, velocity, and variety. Enhanced insight and decision making. Insight and decision making. Okay, so you understand now, this is the big data definition that Gartner has given. Now I think IBM has extended that and is talking about the fourth V also. Okay, they are calling it veracity. Uncertainty of data. One in 3 business leaders don't trust the information they use to make decisions. So they are also, you have so much of data, so there is a uncertainty of data also, right? In one survey, were unsure of how much of their data was inaccurate. 27% of respondents were there. Poor data quality cost the US economy around 3.1 trillion a year. So this veracity also they are classifying as one of the characteristics of big data. The Gartner did not mention it. I think IBM is bringing their own perspective to that. So that's nice. So please read this in detail. That's one of your assignment today. Okay. And listen to the podcast also. So let's take a quick break. It's about 8:26. We discussed the business data, this point. So we'll get into the other things now. So let's take a quick break. Okay. So is 10 minutes good enough? Yeah, 10 minutes. Let's come back after 10 minutes. Okay. Thank you. Back. Thank you, Teja, for the confirmation. Thanks, Hemant. Mallikarjun Prabhuji and Murali. Srini, thank you for the confirmation. Ashish, thank you for the confirmation. So we have everyone almost. Gautam, thank you again. So perfect. So let's get started. Okay, so that's the definition of big data. Big data is high volume, high velocity, high variety of information assets that demand cost-effective, innovative forms of information processing for enhanced insight and decision making. That's what is called big data. Now, how we do innovatively the processing, how do we do it most cost-effective? That's a detail. Okay, that's the solution is general, but the definition is this. How we do it, how different tool sets in the industry do it, they implement these features is a different aspect. Okay, that we will get into detail. We'll get into detail of how Hadoop does this, but the definition is this. So is everybody clear with the definition? Is it very clear? Thank you, Hemant. Thank you. Ashish, thanks for that. Teja, thank you for the confirmation. It's simple, it is in one sense, it's these three characteristics, right? Then you do it in a cost-effective, innovative form. What are you doing? Processing. This is the key. You're processing your data. For what purpose are you processing it? To get insights. And what do you do with that insights? You will do a decision making. Oh, okay, if I sell this product, I can also sell this product. Yes, Hemant, please. Yeah, please. Hemant, you can add that. Yes. What is that? Hemant, you can go ahead and add. I hope you're typing it, or you want to speak? Okay, yeah, please. Efficient processing. Yes. In simple words, efficient processing. It's wonderful, amazing, yes. You want efficiently process the data. The efficiency can come in terms of cost. It can come in terms of the processing logic itself. It comes in terms of so many things. How efficiently you are processing. Without efficiency means what? Not wasting your resources. Anytime we talk about efficiency, it basically simply means you are not wasting resources. With less number of resources, you are doing more. That is called efficient processing. Very nice. Thanks for adding that keyword. That's important. Yes. Okay. So that's what it is. Okay. Then let's move on to the next one. So one of the examples here I have here is astrometry.net. You can go to that. Basically, it watches the astrometry group on Flickr for new photos of the night. So people around the world, they take a lot of pictures and they post it here. And the tools in this website, they analyze each image and identifies which part of the sky it is coming from. And they also figure out any interesting celestial bodies in the sky, like such as stars, galaxies, any distant planets that they could observe. All those things they record it and put it on the website. So this project shows the kind of things that are possible when data is made available and used for something that was not anticipated by the creator. right? So this whole, it's extending, this slide is extending on the concept of information commons. Information commons means you put all the data, you're willing to share the data so that people can use it and then come up with more interesting insights. So to tackle this whole data chaos, you need a solution. You need a solution that can process your data most efficiently, like Hemant was suggesting. Efficiently means efficiently in terms of resources needed to process the data, efficiently in terms of costs involved in processing your data, and the very purpose of why you are doing that processing of the data, so that you can get insights of your data in order to make better decisions around the data. So if you want to do all of this in the universe of this so much of data chaos, one relief is that we have a good news that there is big data management solutions. But the bad news is the fact that we are still struggling to store and analyze the data. So the challenge is still remaining the same, but we have some solutions as a relief now. Okay, that is the relief part. Means that is the good news. The bad news is that we still have to struggle with the amount of data and how more efficiently we can process the data. It still remains the challenge, and that's why it is classified as one of the emerging technology. Now we will put together in perspective. So obviously, with so much of data chaos that's going on out there, right? The obvious thought process would be like, if I cannot solve my big data problems with small computers, I will increase the speed of my computers. I'll simply increase the speed of my servers. I will scale up. So that is called scaling up. Remember we talked about this notion. Let me use this space. You have a computer here, server, with some resources, your random access memory, your processor speed, and the disk space, and so many things, your network bandwidth, all that, right? All the resources. So naturally, anybody, if my old computer is not doing, I'll go on to replace that with a better specs, right? It's basically increasing, scaling up. So I'll increase the speed of my servers and I'll scale it up. I'll get a faster processor, I'll get a faster memory, I'll get everything faster, and I should be done. However, the problem with the scaling is illustrated in this graph. As the time, this is the size and this is the time. The time and cost to process the data grows exponentially. So one of them is total cost. If you see here, the blue line is total cost involved. The processing time is this much. So for the worth of cost that you are putting, the processing time will be this much. As your costs are increasing, at some point you cannot scale up anymore. How much you increase, for the amount of cost that you have invested into increasing your server, is no more proportionate to the costs that you are increasing. Your processing time is getting delayed and your costs are increasing, right? So scaling up is not going to solve you. The pros, the benefits of scaling up is you are using the same server, right? In the scaling up, typically the notion is that you have one server and you are using that only. Okay, so let me put that here. Let me draw that server here. This is my server. I will increase my RAM. I will increase my RAM. I will increase my processing speed. I will increase my other resources. Basically, I'm scaling up. So increasing the specs is called, the notion is called, I'm using this specific word, scaling up. Okay, anybody asks you what is scaling up, means you should be able to know that, hey, I have a server, I'm increasing the specs of that server. That is called scaling up. Okay, the advantages with that approach is that you have less power consumption than running multiple servers. Right? Instead of having multiple servers, you probably have less power consumption. The cooling costs are less than scaling horizontally. You'll be wondering what is cooling costs and all these things we are talking about, but if you have interacted with the data center people who work actually, I was with one of my customers when I was doing hardware sizing for one of the servers. Even in the data center, the amount of yards, the footage space it occupies for that rack, the space, the temperature that needs to be maintained, the air control conditioning, the everything has a price. Even though there's own data center, when they are buying the rack space, the length, the width, the height, and the amount of air conditioning, they have cost for each one of them. So when I was reading this book, the book I referred, by the way, the book I have recommended is called Hadoop Definitive Guide by Tom White. So this is a specific point that I have taken it from that book. So in the beginning I was wondering, then later when I came across that situation, I was thinking, yeah, it made sense. So cooling costs, the rack space, the number of cables you run, everything they put together as a cost in the data center when they build things. So this is especially for those who are running huge clusters and huge data centers. These cooling costs are of high importance for them. So cooling costs will be lesser than scaling horizontally, right? Because you are scaling vertically up. So you have the same rack space and everything. So your cooling cost may be down. Generally less challenging to implement. It's one simple system. So you simply replace these things. So less licensing costs. Sometimes uses less networking hardware than scaling horizontally. If you have multiple computers, then the number of switches that you have to get, the number of rack space that you have to get, the rack to switch to routers that you need to configure, the bandwidth, the pipeline between the servers, all those things will add costs to you. So usually, the advantage with the scaling up is uses less network hardware and then scaling horizontally. So these are the advantages of that. Now let's see what the disadvantages are. The disadvantages is price. The reason we are saying again the same price again is because of the fact that for the price to your value ratio, right? Everybody is nowadays calculating in that. What is the price I am getting and what is the value ratio? When you go apply for a mortgage, right? They are seeing value to loan to value ratio and all that. All those things are doing. So everybody is to this ratio matters. So what is the for example, when we go buy a 3 TB disk for our home usage or a 6 TB disk, the first image, if this 3 TB costs $199 and this one costs $299, right? Immediately the natural tendency is to think where am I getting the maximum bang for the buck? You calculate that ratio, right? So naturally you'll say, hey, I'll rather just for one more 100 I'm getting double the size, so I'll go with this. So that's how even the marketing, all these products that they're designing is all around that only. Whether you go to your cell phone plans by AT&T, Verizon or anything like that, or whether you want to buy a new iPhone 6, you will give iPhone 6 for 8 GB, you will say to $199, or 32 GB, you will say $299. Right? Your bang for the buck is more here. So you naturally want to buy that just for 100. So that's how the marketing, the products, everything is geared towards that. Your price to value ratio matters the most. Right? The disadvantage is greater risk of hardware failure causing bigger outages. How much are you pump? The moment this whole thing goes, everything is on one server, right? If this goes down, if this becomes your point of failure, you are at major risk, right? So it poses a risk for the protection of data, hardware, everything. Generally, severe vendor lock-in and limited upgradability in future. Your vendor locked. If you got your server as a HP, for example, you have to buy the same. Even if you want to scale up, all the options are around only that support that architecture. Is it 64-bit or is it 128-bit or is it 8-core or 16-core? is the RAM 128 GB RAM, 64 GB RAM. Everything you have to buy that is compatible to only to HP. By the way, I am not doing any very important, because I am not talking anything against HP or IBM's or EMC Square. When I am taking these names, only I am taking it for the example sake. So I am just saying that because if this video gets leaked out somehow, or if I put it freely and somebody comes and asks me why are you talking about HP and all that. So I am not vendor biased or anything like that. I am just saying it for the sake of saying it as an example. So you are not logged into vendor by doing this. Okay, no, sorry, you are logged in. You have to get only the same thing, same processes. So these are the disadvantages of this process. So pros and cons. Anybody has any questions around this? Pros are less power consumption, cooling cost, basically costs, implementation is less challenging. Again, this is also cost only, licensing costs. Basically costs and resources, the way you would process will be less in the case of scaling up. In the disadvantages is the price to value ratio will be high. Since you are doing everything on one computer, what if that computer server fails? Then the architecture is monolithic, basically, right? So you have a point of failure there, and you run off higher risks. And also you have vendor lock-in. Okay, so those are the disadvantages. So let's see what are the other alternatives. So then you will come back and say, hey, no, I will not scale. Scaling out doesn't seem to be giving me the good amount of price to value ratio. Instead, what I want to do is I will scale out. Okay. Remember here, we use the two terms here. One is called scale up. Scale up means growing vertically. Everyone understands? Teja, Murali? Yeah, okay, perfect. Ashish? Everyone, I hope everyone understands. But when it comes to scale out, you are going this direction. Actually, let me do this. Scale out means horizontally expanding. Okay, we'll understand what that means. So generally, horizontal scaling, it's also the term you would use is scale out or horizontal scaling. Right? Horizontal scaling means what? Horizontal scaling generally refers to adding more servers with less processors and RAM. So you have servers, more servers added, so you're expanding like this, but with less power and RAM, less resources. It's fine, but I have more of them. Right? So to be able to, yeah, basically this is usually cheaper overall and can literally scale infinitely. Although we know that sometimes there are usually some limits imposed by the software and other attributes of the environmental infrastructure in general, but you can increase as many as you want. And the cost to value ratio in this case is proven to be much cheaper. Okay. So basically the idea here is that we would be able to process the data within a reasonable resources and time. So this whole scaling out approach will offer more superior results. So how do, Hemant has an interesting question. How do a company identify the break-even point, whether to scale up or out? So that comes into your, this is a gap the process analysis. So if you can see here, the processing time for scale out, right? is basically the amounts of data. It is in a typical, if you have seen, why do we have these clusters set up, right? The idea is, even for example in our traditional architecture, Hemant, if you see, let's say even if you have a cluster, your application server or your method server that's been clustered, but the processing is not distributed completely. It's only the requests that are distributed, but the processing of the data is not completely distributed. Something like a grid, exactly. Yeah, Murali, yes, you're right. Grid computing, exactly. In data warehousing, you have the compute grids, right? The data grid and the compute grids that does that. Yes, exactly. It's very similar. Yes, Murali, you're absolutely right on that point. Correct. So the question here is, how do a company identify the break-even point whether to scale up or scale out? So you basically approach the hardware vendors, the companies, all these HPs, Dells, EMCs of this world. They have realized that whatever the amount of insights, the amount of power that you are getting to analyze the data. So let's say they would go from your metrics. What do you call that? I kind of slipped on that. What do you call that? KPIs, right? KPI, right? What is that? Key your metrics, basically. Key performance indicators. Thank you. Perfect, Murali. Thank you for helping me that. So the key performance indicators, when you do it scaling up versus scale out, they found that the key performance indicators here are your costs, your amount of data that you can process. So for example, if one job that takes about 1 TB of data, and if in a scale out scenario, if it takes let's say 4 hours, 1 TB actually won't happen. Even for disk operation itself, depending upon that, can take more than hours, many hours. But let's say it takes about 12 hours, right? Then what is my disk? What is my processing time? That's one of your processing time is one key KPI. The amount of data, volume of data that I process is another KPI. So you do the KPI. So you will do a POC. So your question, if I go back to your question, how do they? This is a very interesting question. Very nice question actually. Yeah, I'm looking for the parameters based on which they do analysis. These are the ones, Hemant, the KPIs. Your amount of data, your speed at which you are processing your data, the costs involved for that infrastructure, all those things, the KPIs, they will put together, and then they'll do, okay, I'll do for this given job that takes 1 TB of data, how much time it takes. So you do one exercise with the scale out. In the scale out, you'll do one, let's say, I'm just using one parameter here, okay, Hemant? So let's say I have a 2 GB of RAM. For the same job, how much time it took? Maybe let's say it took 24 hours. For 4 GB of RAM, how much it took? Maybe it took 18 hours. For 8 GB of RAM, I'm scaling out here. How much time it took? Maybe it took only 12 hours. For 16 GB RAM, how much it took? Maybe 8 hours. Like that, you scale out. And then for the scale out configuration, you put all your costs, all the KPIs. Cost is one amount. RAM is one KPI. Cost is another KPI. The processor speed is another KPI. So you basically arrive, you benchmark basically. All these companies, HP, Dell, all these companies, what do? When they partner with all these application, product developers, that's what they do, the benchmarking. Remember, when we both worked together at PTC had tied up with all these. By the way, for those of you who don't understand, PTC was one of the company that had their product offering on Java. So they partnered with all these companies like HP, Dell, and everybody. Solaris, those days they used to do with all these companies, and they benchmark, right? So those are the key KPIs. And then what you will do is, in your next exercise, scaling out exercise, you will keep the resources very minimal, cheap, and then you will start increasing. What if I do with 1 node? What if I do with 2 nodes? What if I do with 3 nodes? How is that my costs are increasing, and what is the bang? What is basically cost to value ratio? That's all. It's as simple as that. and they give these different configurations, and then the companies will say okay, and when they go to the vendors, when they go to the organization that want to buy, here is my software, here is the benchmarking results, you go choose your package, right? That's what how Amazon also does it. Amazon has different tiers in the cloud computing. Simply they already did all this math, and that's how they are giving this. Amazon, Azure, all these cloud computing architectures, now they have, this infrastructure has grown, all these KPIs have now already in place now, Hemant. So the cost effectiveness of all running these different architectures, that's why distributed computing has become now the rage. Okay, so that's where Hadoop is playing a huge, it's actually literally shaking the industry now. Especially all the companies like, data warehousing companies, the traditional data warehousing companies like Teradata, MicroStrategy, they are all now forced to rethink about their solutions around big data now. Everyone is doing all this, Teradatas, MicroStrategy, Cognos, everyone is now into this revolution now, because they have to now, because Hadoop's arrival, which has become pretty much open source and free, is shaking the industry currently. Anyways, so I hope that answers your questions. No. In memory also is, in memory and distributed computing are going to hand in hand now, Murali. Yes, I am not saying it's obsolete. In memory is also HANA. You're talking about HANA and all, right? Yeah. They're also, everybody has their perspective now, and they're actually coming up with hybrid of both in memory and distributed also. In fact, if you see on the Hadoop now, if you go back to Hadoop's one of in the ecosystem, let me clear this. I think the discussion is going in a very nice, interesting questions. So this is a good advantage of having nice, experienced people like professionals like you all on the call on this training. So if you go to Apache Spark, oops, sorry. So on Hadoop, see, in memory. So you have, now we will discuss, we haven't come to this point yet, Murali, but my point here is, now in memory MapReduce is becoming a huge hybrid concepts of running in memory computing with distributed computing. When you combine them together, you are it's resulting in even more amazing results, faster, more efficient. Okay, so we'll get to it once we understand Hadoop motivation, why Hadoop exists, what it is solving in the industry, then you can be able to appreciate more. But so the answer is, we are not obsoleting. The in-memory is also the emerging way of computing. That's also equally important. I hope that answers. Okay, thanks Murali. Thanks for bringing that up. Okay, let me actually copy that into your notes. References. Anything that we refer, you could. I'll put a note. I'll record it here. That way, you can refer to it if needed. Where is the references? Oh, reading reference. Okay. Just bear with me here. I'll offline before I send it, I'll beautify it. Don't worry. Okay. Okay, I have it there. Okay. Where are we? Okay, what were we discussing here? So yeah, basically you want to scale out. So let me ask, let me take a pause here. Let me ask Teja. Teja, can you please tell me, increasing the, so I'm going to make a statement, Teja, you have to say true or false. Increasing the memory of my compute from 2 GB to 4 GB is called scaling out. True or false? Thanks, Teja. Perfect. Mallikarjun Prabhuji, can you say, please, it is true or false? I will repeat it again. Increasing the memory of my compute from 2 GB to 4 GB is called scaling out. True or false? Thank you. I hope, yeah, correct, perfect. Now let me ask Gautam, can you please tell me what is scaling out means? Increasing the specs of the one single computer or adding more computer servers to the grid? Which one is? Adding computers is scaling out? Adding more servers. Perfect. Perfect. I think now everybody got it. Very good. Very nice. Thank you. Thanks for being very supportive and interactive on this. So you all got it, right? So the pros, the advantages with this is, by scaling out, much cheaper than scaling vertically. It's actually proven to be much cheaper. And it brings you all the other advantages of having it high available, fault tolerant. Means if what I mean by fault tolerant is, let me explain that again. Oops. You have three things, three servers that are running in tandem as a cluster. So I use the word cluster also for those of you who don't understand. A cluster is nothing but a collection of servers working together as one single unit. Okay. For majority of you who are experienced, you know what it means. But for those of you who want to understand what a cluster means. So anything you don't understand, no question is dumb question. Please, okay. Please, if I don't mention, if I'm using a specific terminology and if you don't understand what it means, immediately ask. Okay, please. So cluster means a set of nodes that are acting together as one single unit to process the data or to process anything. Okay, that is called a cluster. Okay, so it's much cheaper than scaling vertically, and it's easier to run fault tolerance. Fault tolerance means if this goes down, I still have other two things active and live that can take the load. So fault tolerance, it is tolerant to fault, means if my one of the server breaks, then I have other nodes in the server, in the cluster, that can address my processing needs. And it's easy to upgrade also. Once you know what this is, that is how all these companies, like again in the cloud architecture, right, they figured out all the scripts. All the you have one server, duplicating that node is like a click of a button nowadays. So it's easy to upgrade now. Okay. The problems with this approach is obviously more licensing fees. Okay, you have to pay more licensing. Cheaper in terms of buying hardware, but more licensing. Bigger footprint in the data center. Right, the data center footprint also matters. Like I said, the size of the rack space, the length, width, they have costs. And literally I was astonished to see, but they have costs for everything. For each cable they use, for the switch they use, the router they use, the length, breadth, the height, and what is the minimal air conditioning compliance that you need to have in the data center. All that cost will be divided across all these servers. That's how they calculate. When Amazon is giving you for a different tiers at pricing, they already did all these calculations. How much would it take for me to put that extra router for your server? That's why you have this single tenancy, multi-tenancy, shared tenancy, all these architectures are there now. So they calculated all the prices now. So it's all out there. So bigger footprint in the data center. higher utility costs, electricity and cooling will be more because you have multiple servers. Possible need for more networking equipment, switches and routers, obviously, right? So these are the pros and cons. Now let's see what Hadoop does. Hadoop takes this approach to big data by relying on commodity servers. I'm going to write this down here. In fact, let me write it down in our handbook. Oh, where is my handbook? Just give me a second. Yeah, sorry. We discussed about distributions and challenges, right? Pros and cons. Hadoop addresses by using commodity software, commodity hardware. By using commodity hardware. Actually, it's here. Okay. Okay. Sorry. Okay. Yeah. Okay. So Hadoop addresses these challenges by using commodity hardware. Let's understand what commodity hardware means. Commodity servers or commodity hardwares are nothing but, in terms of specs, they almost match the enterprise graded servers. Okay, but in terms of the costs involved, it's going to be very cheap. Okay, so let me explain that in a second. Okay, give me a second there. Basically, Hadoop takes the approach of addressing these issues for big data by relying on commodity servers and providing an infrastructure that does data replication, and it also has a degree of tolerance to faults which is inherent in these distributed systems. So that statement, let me hold on a second. Let me write it down here. Okay, Hadoop takes this approach to big data by relying on commodity servers and providing an infrastructure that does the data replication and has a degree of tolerance to faults, basically fault tolerance, which is inherent in distributed systems. So basically Hadoop uses commodity servers or commodity hardware. A commodity hardware is nothing but oh, okay, what is this happening here? Just a second, guys, just give me a second. Okay. What is happening here? Okay, fine. Yeah. So I'm sorry, guys. So commodity hardware is nothing but your it is very close to your enterprise grade specifications, but it is cheaper. You go, remember, you, for example, if you want to buy a home desktop for your home, right, you can go to Apple store, go find a new 5K Retina iMac and buy it for $4,000 and bring it back home. Okay, what you did is you went to an enterprise graded server or a desktop, and you went to a branded company like Apple, and you bought it and came back home with a huge hole to the pockets basically. The other alternative is you go to your nearest Fry's or some kind of an electronic shop, bestbuy.com or whatever. They also have some Genius Bar and all that. You go there, you go to this electronic shop, you go choose all the components, your motherboard, your processor, your the shell, the DVD writer, the hard disks, the cables, everything you buy. Okay, but you're buying it not from a company like Apple or IBM or Dell or EMC Square or anybody like that. You're buying it from a cheaper place, some third-party vendors. But what you did is you paid less amount of money, you got a cheaper price. Even if it breaks, you don't worry about it, right? But the specs, you got better specs than the iMac desktop server that is being sold in the Apple store for a cheaper price. You paid $4,000 there, for $2,000 you got almost similar specs or even better specs. That happens, right? Sometimes some people build the computers, is it not? So that is what, if you do the same thing, I took the analogy of buying a home desktop here, but if you do the same thing for your data center, you go to third-party vendors who are selling the hardware with not so many of bells and whistles that typical top rated company sells. You don't have enterprise licensing, you don't have enterprise support. If you don't need all of those things, why go buy from HP or Dell or IBM and get locked for that vendor for the rest of the life? You have to buy now. Once you go buy, if I go buy an Apple thing, I have to buy the same exact connectors, I have to buy the same everything that matches that, right? So you are locked in to one vendor. You are logged into one specific vendor. But commodity soft hardware means that hardware which is available for a cheaper price that can match the same specs, but it doesn't come with all the licensing costs, all the support and all that. Okay, that is what I mean by commodity hardware. So I drew an analogy between buying a home desktop and the data center. Okay, so when I mean commodity hardware, I do not mean buying a cheap laptop in Costco.com or buying a used refurbished laptop for Thanksgiving. I'm not talking about that. I'm talking about, in terms of spec, it is the same as you would buy from an IBM or from an HP or anybody like that, but it is cheaper because it's coming from third-party vendors, and it does not come with too much of licensing support and all those features, bells and whistles. Okay, that is what I mean by hardware, commodity hardware. Is everybody clear with the concept of commodity hardware? Thanks Hemant, thanks Teja, thank you Srini for the confirmation. Good, everybody is Mallikarjun Prabhuji, thank you so much. So commodity hardware means something that you can buy of the same specs for a cheaper price in the market. Okay, so Hadoop uses commodity hardware. Okay, remember that fact. Okay, Hadoop uses commodity hardware. Just remember that. Let's park it aside. Okay, we'll move on. Hence this era of distributed systems. Okay, better solution is to use multiple machines simultaneously for a single job. That is the notion. What is a distributed computing architecture? It's simply for a given job, you will distribute the job in such a way that multiple computers, machines are simultaneously working on that job, parallel processing basically. Yeah, okay, that is called distributed computing. Okay. Okay, now let's discuss the challenges with the distributed computing. So distributed computing idea is what? One job doing one job with multiple machines simultaneously. That is called distributed computing. Okay. So what are the challenges? What are the challenges with the distributed computing? Let's see that. The first problem to solve is hardware failure. Okay, hardware failure. The first problem to solve is hardware failure. As soon as you start using many pieces of hardware, the chances that one will fail is highly fairly high, right? The moment you have multiple computers, the chances of one going always down is always there. Let me draw here. If I have a computer that's doing a node, a cluster of nodes that are doing heavy work for me, the chances of one going down is always there. So a common way of avoiding data loss in this case is by the concept of what we are going to call it as replication. Okay, replication. Replication means what? You have a piece of data, you make a copy of that data on the other disk. Yeah, correct, Gautam, perfect. You keep copying. Let's say if you have another grid, you make another copy of that same. So that's called replication. So if one dies, if we had another one copy here, if this dies, you still have a copy elsewhere. Okay. So common way of avoiding loss is through replication. Replication is nothing but your redundant copies of the data that are kept in the system, so that in the event of failure, there is always another copy. This is how traditional RAID systems work. I don't know if you have configured any of your computers or your storage devices in RAID. Or RAID stands for something. I forgot what it was. What is it? What is RAID is called? Oops, sorry. Where is my browser? Oops, I think this is not enabled. RAID disks. Now, rapid application development is different. That is our RAD. RAID is basically redundant, something like that. If you go here, as you can see, redundant array of inexpensive disks or redundant array of independent disks. That is called RAID. So you can read this. RAID is basically different configurations in which the RAIDs also work similarly. You have one copy, then it makes a copy of it. RAID 1 means it writes parity bits between the alternative servers, and in one of the RAID configuration, RAID 2 means it will make a copy literally. You write to one disk, it will make a copy immediately to the other disk. So different ways are there. Okay, so that is what it means by RAID. So we solve this problem of data loss using what? Replication. The solution is what? Replication. Okay. So Hadoop also has this concept of replicating. So Hadoop has a file system. Okay, just like the way if you are now running this whole thing on your computer, if you look at your computer, let's say Windows machine, you have a C drive and a D drive, and when you go into C or a D drive, you see a file structure, structure, and then you go into deep dive into each of the file system, right? So you are running a file system right now. For example, in Windows machine, probably you'll have NTFS as a file system. Popular file system. Similarly, Hadoop has a file system where all the data is actually stored. It is called HDFS. HDFS means Hadoop Distributed File System. Okay, Hadoop Distributed File System. Everybody understands that? Hadoop Distributed File System is where the actual data, all the files are stored in Hadoop. Okay, and Hadoop Distributed File System basically stores the data. Okay, so let me not too prematurely use so many jargons and then confuse you. So let's take one step at a time. Okay, so let's say you have one computer. Okay, and then let's say you want to read 1 TB of data. Let us say you have one machine and your disk's read speed is 100 MB per second, and usually that's how these computers come with 100 MB per second, and they can read, they'll have 4 IO channels, means you are reading 400 megabytes per second. Okay, now you tell me how much time it takes to read 1 TB. Everybody please do a calculation. 1 TB means how many GB? Can anyone tell please? 1 TB means how many GB? 1000 GB. Yeah. 1 GB is how much? To be precise, 1024, but for the discussion sake, let's call it 1000. Okay. So 1 GB is how many megabytes? Yeah. So now please do a calculation. If you can read 100 megabytes per second, and if you have 4 IO channels on your computer, then that means you are reading 400 MB per second, right? So how much time would it take to just read 1 TB of data? Can anybody see? Tell me please. Gautam has got with came back with some figure. Very good. Anybody else wants to give an answer? Nobody wants to do the math? So give me in minutes. Basically it takes roughly what Gautam said, 45 minutes to read. Okay. With 4 channels it takes 45 minutes to read. Now what if you have 10 machines with the same 100 MB per second reading, and we have 4 channels, let's say. How much time it takes? If one machine takes 45 minutes, how much 10 machines will take? Yeah, Teja is correct, Vivek is correct, everybody. 4.5 minutes roughly. Yes, Shrini, you're right. So you see this now? The moment you increase the same spec, you have multiple machines, it will take about only 4.5 minutes. Right? So that is the advantage of having a distributed architecture. So if your data is distributed like that, and if you can read it like that in parallel, then you can efficiently, what takes 45 minutes is reduced to 4.5 minutes for you to process. Okay, that is what is distributed architecture in typically means. Reading is I use the reading just to give a notion, but ideally distributed architectures not just read, but they actually process the data also. We'll get into the details later. Okay, but you can appreciate the fact that by multiplying the nodes, your read IO operations are becomes more easy and faster. So the challenges with the distributed systems is like programming complexity. The second problem is that most of the analysis they need to be able to combine the data in some way from different nodes, and typically like the data read from one disk may need to be combined with the data from another any other, let's say another 99 disks, right? So your programming complexity becomes very, very tough, keeping the data and the processes in sync, right? So what I mean by that is, like if you say you have here, let's say you have 10 servers like this. Let's say you have written a programming logic. This is your business logic, analysis, process analysis logic. Now when you run this program against the data here, you would need to make sure that your data specific state of data as you apply your logic across here, and here, they all should be in sync, right? You cannot have one particular state of data different from the other. Then you will run into all kinds of consistency problems. So when it comes to distributed systems, it is important that whatever the system, the framework should be able to keep both data and the processing in sync. Let's say let's say you have for an employee ID equal to 123. Let's say the HR wants to update the salary equal to 2,000. Let's say $2,000, and one HR guy does this on here, and the another HR guy, without the knowledge of the other guy updated, he will go and update it to $3,000. So the information should be in sync, right? The cache between them should be shared in such a way that both reflect the same data. One cannot update to 2,000, another cannot update it to 3,000. They immediately go out of sync. So your logic Your data, state, everything should be in sync. That is what it means. So keeping the data and process in sync is a huge challenge. It involves a lot of programming complexity. You would need to write your cache servers, you need to write your cache services, you need to have your persistence mechanism synchronized. So you would need to make sure all of those things are done in place before you can propose that as a solution. So that is one of the problem or challenge. Not a problem, it's a challenge. The bandwidth restrictions can pose challenges. Partial failures among the nodes can pose challenges, right? So various distributed systems allow this whole data to be combined from multiple sources also. But doing this correctly is very, very challenging. That's the point here. So we will introduce now a new programming paradigm called MapReduce. Okay? MapReduce. So MapReduce provides a programming model that abstracts the problem from the disk reads and writes, and it transforms it into a computation over set of keys and values. So basically what this MapReduce does is, think of MapReduce as a layer on top of your framework that does the distribution. So as a programmer, when you're coding in MapReduce, you don't need to worry about keeping the data in sync, process in sync. All these things are taken care by MapReduce. Okay, Hemant has a question here. I have a question. For example, I have a data of 1 TB in one machine and make that as a distributed system, meaning the other systems will also have 1 TB of that data copied to each other node. Okay. So you have 1 TB and then you are copying the same thing. You are coming up with multiple machines with the same configuration. Okay. So then what is the question, Hemant? In that way cost will increase, nah? It will increase. In that way cost will not increase if the data keeps increasing. I did not understand. Okay, let me read that again. I have a question. If I have 1 TB of machine, okay, make that as a distributed system, meaning the other systems will also have 1 TB of the data copied to each node. The other systems will also have 1 TB of the data copied to each node. So what the idea is, if you had 1 TB of data, so you are talking about TB, okay, the size. In that way the cost will not increase. So you are asking cost will increase, right? You are saying cost will increase if the data keeps increasing, right? That's what you are saying, right, Hemant? Yeah, it happens in both cases. Yeah, scale up or scale out, you are saying the cost will increase. Cost will increase, but the power is not in cost, just the storage. You are only looking at the storage aspect, but processing the data is also another aspect. Okay, so when you scale out, usually what you do is, you don't choose the same spec. If you had one supercomputer earlier, in scale up scenario you had a mid-size computer, you scaled up to a supercomputer. That's one scenario. In scenario 2, you scale out, you had a mid-size computer, but what you do is the mid-size computer you will make it to small size computer, but you will have 100 of them. No. Okay. In scaling out, what you did is you didn't have the mid-size computer, but the data, yeah, amount of data, hard disks you can throw it. The problem with with the clusters is not the hard disks alone. It is the processing processors also matter. The bandwidth also matters. All those other things also play a role. Yeah, whether you can have same amount of data, or you could even 1 TB of data you had to. Let's say you are running a small business that grows 200 MB per month, let's say. Okay, for a discussion, let's say 200 MB per year, just as a discussion sake. Okay, it's not realistic. So 200 MB per year means in 5 years you will get 1 GB. So 5 years 1 GB means 1 TB will take about what 50 years, 500 years. Big system may also fail, but big system means what? One monolithic system or multiple system. You have, this is a distributed system, big system, or you meant once the same server being increased specs. One system will fail also. Yeah, that is why, that is the thing, right? Scaling up is not good. That's the whole point. I don't know if everyone caught that point or not. Let me draw here. You have, oops. So if you have a computer like this, oops, okay, not, this was your original computer. Scaling up means what? You are increasing the size of this computer like big. How much are you big, it will fail. That is what we discussed, right? One of the negative aspect, the cons that we discussed was, how much you scale, it may fail. Failing is inevitable. It will fail. Even your Amazon server will fail. But the beauty of scaling horizontally or scaling out is when you distribute the data in such a way that even if one fails, your point of fail, in this case this is your single point of failure. The moment this fails, that's it, your whole system is down. You can't do your business. Here if in the distributed horizontal scale out scenario, if one system fails, you still have other grids that can do the work for you. So that's why scale out always wins. Okay, important guys. Remember, when you scale out, your specs are probably even lesser than what you originally had. But you're distributing the load across multiple nodes. I'll throw rather, instead of investing $4,000 here, I'll use the same for, if let's say if this cost was $400 for example. This is let's say $2,000 and $4,000. Instead of investing another another $3,600 on the same machine to increase the specs, I'll invest the $4,000 to buy a smaller machines, 10 of them, and then store the data, distributed it across with copies, replications. That way, even if 3 of them die because they are cheaper, I don't mind, because I have my data is still on, my processing is still on. Okay, so the entire, this is the exact model the cloud architectures are working. All the companies like Rackspace, Amazon, how do you think that they are making now more money with this architecture only? So it is proven that scaling out has proven now is on record, it has been proven to be the most effective way of doing your compute. Okay, that answers Hemant. Yeah, thank you. Okay, we were discussing about MapReduce. So your MapReduce will abstract you as a developer from all these complexities, your bandwidth restrictions, right? Partial fail scenarios. All these things you don't have to worry anymore in the MapReduce. All you have to do as a developer is write a MapReduce program that will process, that does the distributed computing on your data, and the framework will take care of all the complexities involved in the background. How? That is going to be the detail. We are going to discuss that in detail. Okay, but at least understand that MapReduce is a programming model. Or you can say framework. you would interchangeably use this word model or framework. Excuse me. Okay. So your MapReduce programming model will do that. It will abstract you. You don't have to worry about all of these things. You just, if once you understand MapReduce, you just write programs. The cluster, the framework will take care of all the complexities behind the screen. So hence Hadoop comes into the scenario. What is Hadoop? Let's understand that. Apache Hadoop is a framework platform that allows for the distributed processing of large data sets across clusters of commodity servers using a simple programming model. Couple of things. It is a framework or a platform. Okay? Hadoop is a framework or a platform. What does that framework or platform does? It does distributed processing. Of what? Large data sets across clusters of commodity servers using a simple programming model. So many of these characteristics are there. It is a platform, first of all. Like you have iOS platform, Windows platform, right? Similarly, Hadoop is a platform. And what is that platform does? It does distributed computing. Of what? Large data sets. So if you have, let's say, if your company has only, maximum your business has only 1 TB. Okay? That's all. If you have only 1 TB. And you know, even in next 10 years, you are not going to increase more than this. Now, if you go buy Hadoop, then your processing speeds will be low. And you probably will get slowed down. You won't be able to, in fact, it will slow down your business. You should never go for Hadoop if your data sets are lesser than 1 TB or 2 TB only. Okay, never go for that. This is more optimized for large data sets. Very, very key. Hadoop is not good for smaller data sets. Important. Everybody please understand this concept. Hadoop is not good for smaller data. You probably will become slower. Okay, to process the data. The more the amount of data you put onto the Hadoop system, the efficient it becomes, because the cost to value ratio, remember that. It is more efficient if you have more data, because processing, processing, let's say processing 1 TB data with a regular system will take, let's say 10 minutes. Hadoop will take 1 hour. So you're better off with your regular system. But if you have 4 TB, your regular system takes, let's say, it takes about, because you are scaling up in this case, at a point will come where your cost to ratio will become, this will take, let's say it will take 2 hours. But your Hadoop will take only 1.5 hours. So now you are seeing benefits. Now what if this 4 TB increases to 10 TB? This will take 8 hours. This will take hardly 3 hours. So you pay more, you get better response with Hadoop with large data sets. Very, very important. Okay, it's meant for large data sets, not for small data sets. If you somebody proposes, that's why this is meant for big data, not for regular data, normal data. Okay, that's very keen. Across clusters, it uses multiple clusters, and it uses commodity servers. We discussed what a commodity server means, and it uses a programming model called MapReduce. reduce. What that map reduce, don't worry now, okay? It will become very clear for you guys. Okay, it will become very clear. Don't worry about map reduce, what map reduce means. So first just take it as it is for now. Okay, it uses the programming model called map reduce. It uses the hardware. So there is software programming which is called map reduce. Hardware is the commodity servers, and the commodity servers are put into a cluster, and it is used for the large data sets, and it does a distributed processing, and it is a platform. So 1, 2, 3, 4, 5, 6 characteristics. Okay, so please remember this. Everybody please remember the 6 characteristics. Tomorrow I will ask everyone. So I will also put this in your student handout. So go through the student handout after this class, but make sure that you understand this. What is Hadoop means? You should be able to explain this. Hadoop means it's a framework which allows distributed computing on large data sets across clusters of commodity servers using a simple programming model. So you should be able to tell all these 6 characteristics. Everyone understands the definition now? Please give me a quick yes. Thanks Hemant, thanks Srini, thanks Ashish. The concept is clear, right? Murali, thank you so much. Vivek, thank you for confirming. Mallikarjun Prabhuji, thank you so much for confirming. So you should be able to articulate the 6 characteristics tomorrow. Okay, good. It's an open source project governed by Apache Software Foundation. Okay, it is an open source project. So there are 2 primary functions. Okay, whenever you talk about data, there are 2 things you do with it. One is processing the data, one is storing the data. First of all, you want to store the data on the disks. So you have disks here. You store the data, right? And then you process the data. Then you have a program that sits somewhere here. The processing logic, it processes the data. It reads the data, processes the data, and then it does something with it, whatever. So there are 2 aspects of it: processing the data and storing the data. Storing the data is stored on the, we already discussed. What is HDFS? Can anybody type in the this one window, please? What is HDFS means? Hadoop distributed file system, very important. Yes, thank you. Hadoop distributed file system. So it stores the data on the Hadoop distributed file system, and the processing is the programming. This program is called MapReduce. So there is MapReduce model, MR. I'm going to use the word MR going forward. MR means MapReduce. Generally in industry they will say MR jobs. MR job, they'll say MR job means MapReduce job. Okay. So you have a processing data component, which is your program, and you have the storing the data component, which is basically you are storing the data, your file system, which is HDFS. Okay. So the difference between traditional RDBMS and the MapReduce, right, is this. But keep in mind that in general your MapReduce can be seen as a complement to your relational database system. Of course, I am going to talk about the differences here, but in general you have to look at MapReduce as a complementary to your RDBMS system. So MapReduce in general is very good fit for problems that need to be analyzed when the whole data set is like basically it is a very good fit for batch processing, particularly for any of your ad hoc analysis that you have you want to do. Then MapReduce is a very good one, whereas a RDBMS system is very good for point queries or updates where the data set has been indexed to deliver low latency retrieval, right? and update times of relatively small amount of data, then your RDBMS is good. RDBMS is good when you have point queries, means select or not select. Let's say you have a query something like select star from employee table where employee ID is equal 1, 2, 3, 4, or update the salary of a particular employee. You write a query. So it's very good where the data set is low and also your latency. Latency means what? The round trip from the client to server. What is called latency? Let's say this is your computer, and let's say this is where your data is. What is latency means? The round trip from here to here and here to here. You ask for a data and then the data comes back. That is called latency, right? So your RDBMS systems are very, very faster. You ask for a query, then you get the answer immediately, very fast. But whereas the MapReduce is not like that. MapReduce is batch oriented. What? It's batch process. It takes the requests from the customer, from the client, does the processing for a while asynchronously, and then responds back. Request and response. Hadoop distributed file system, Hadoop distributed, okay, yeah, request and response, correct. So it is a batch processing. MapReduce suits very well where the applications, where the data is written once and read many times. Whereas in a relational database, it's good for data sets that are continuously updated also. Okay, so let's look at the kind of differences here. The data size wise, traditional RDBMS can do up to gigabytes and maybe up to a TB, but MapReduce can handle up to petabytes of data. So the access way of in a traditional RDBMS is very interactive and batch. It supports both, right? MapReduce only does batch. Okay, only batch processing. Everybody understands what it means by batch processing versus interactive processing. Interactive means you ask for something, you get immediately a response. You go to YouTube, for example, or you go to Amazon.com, you type in Sony TV, means immediately you get the TVs. That is a immediately responding interactive system. Whereas if you go to a system where you submit a job and come back next day and then the results are there, that is called batch processing. So Hadoop is a batch processing system, not a interactive processing system. How do you add the interactive layer to the Hadoop in general is a separate topic. We will discuss that later. Don't worry about it for now. But in general, by design, it is batch process. The updates are read write many times. You can read you can read data as many times as you want. You can write data also. You can say update my table, set salary equal to $3,000 where employee ID equal to 1, 2, 3, 4. You can say that easily. Whereas in the case of a MapReduce, usually it's write once. You write the data to the system and then you only majorly do read many times. You don't update the data on the MapReduce. If you update the data, probably what you would do is you would take the data and write to a new, make a copy of the data and update it rather than that. Okay. Of course, Hadoop 2.0 onwards, the incremental updates and appends are now supported in Hadoop, but that's we will discuss. Don't worry too much about it for now. Okay, we'll discuss all those things in detail. Structure, static schema, whereas it's dynamic schema. Static schema in RDBMS means what? Before you can write to a table, for example, you have to define the schema for the table. You have to say my table has employee ID, employee name, salary, department. You have to define the schema first. Then you can bring the data into the table. The data is here. Let's say it can come into the table afterwards. So you have to have a static schema. You cannot. You can change the schema later also by doing an alter table or anything like that. But it's tedious. But generally you have to define the schema before you can do it. whereas it's dynamic schema. In MapReduce, you write to the file without, even if you don't have a schema ready, just dump the data into the HDFS, and then later you can give, okay, my first column is this data, second column is this data, third column means this. You can give the schema later dynamically. Okay. Integrity is high, integrity is low. Integrity means what? Integrity means basically between among the clients that are accessing the data is integral, means it's consistent across all the nodes. Whereas the integrity factor in a MapReduce can be slow because the data is being processed in a batch process. So it takes, some of the jobs will run for 24 hours. Some of the jobs with big data can run for 48 hours also. So it's not integral yet. Until the whole job finishes, you can't get a good assessment on the data yet. It's not consistent and integral. Scaling non-linear, whereas here it is linear. So the benefits of running a MapReduce program linear, you just add more nodes, your processing power increases linearly. Whereas here it is non-linear, the scaling. Your cost to value ratio is not straight as you would do. Okay, so those are the differences, fundamental differences of RDBMS versus this. So I think I will stop right here. It's about 10 o'clock. We are on the time. So let's go back to a student handbook. We discussed up to this point only. So in the student handbook, I'll make some changes and then send it to you. These topics we did not discuss. Your assignment for today is, make sure, for those of you who still don't have your virtual machine up and running, have your virtual machine up and running. Then your second assignment is review this 4 V's of big data that IBM website has. And your next thing is, so this will take about 10 minutes. This will take about 15 minutes, half an hour of your hands-on today. You have to go listen to this big data podcast. Click on this. If you click on this, it will come to this website. So it takes about 16 minutes. Listen to this simple audio. Okay. So those are your this thing, and okay, hold on a second. For those of you also, if you go to the LMS system, oops, give me a second. Not like this. Okay, Control Shift N. So when I log in, right, you will see Hadoop. Yeah, this is the one, Hadoop Big Data Hadoop Developer Training. You go into the training. By the way, class 0 pre-training kickoff is right here. For those of you who don't have the access, so you can access that. So today's class 1 will also come here. In the next half an hour, you'll see that. But most important thing is, you go to this. For those of you who have already set up your machine, virtual machine, go into this. What is this? Okay, let me erase everything. Yeah. I hope you followed the video and also the instructions here. Once you've done that, there is this link here, assignment. Okay, click on this link, please. You see this assignment? Everyone, please click on this assignment link, and then you do the whole. Majority of you already up and running, right? You simply, what you do is you type in the details here for me. What is the available RAM on your machine? Okay. And there are a couple of, I think, I don't know why it is not coming yet. Okay, you have to start the assignment, I think. This is not working, so don't worry. I thought this was working, so I have to figure it out why this is showing like this. It should ideally be, you should have a start button here to start it. Because I'm running in this mode, it didn't enable the JavaScript, I think. Okay, don't worry about this assignment. I'll have to figure it out why it is not coming. So what I would want you all is, after the class, if you go here, there will be the second class 1, today's student guide also will be there, student handout. Okay, go refer to it and revise what we have discussed, and please do the assignments given in this, which is reading the references, this one and this one. Okay, please do these 2 things, and we will meet exactly same time tomorrow morning, 7 a.m. Central, 8 a.m. Eastern time. Okay, is everyone fine? Perfect. Thanks, Murali. Thank you all, and you all have a wonderful day. I'll not have any hands-on lab today because it's all basically nothing. We're just discussing thing. So tomorrow or day after class onwards, we will have hands-on also. Okay, so just do that. If possible, if you are more curious, you can also go to this one, practice Linux commands here. Okay, just simply do, there are Linux commands I have given here. Open up your virtual machine and then just practice these commands if you want. Just take some dummy files and just do practice this, that's all. Okay, I'll also include the link for this one. Okay, so please, most important thing is do this. Optionally, if you are interested, do the Linux commands also, exercise. Just for your own practice, just take a dummy file, move it here and there, copy it, just experiment, just to get your hands warmed up on the Linux commands. That's all I have. Thank you all, and you all have a wonderful rest of the day, and same time tomorrow morning, and the video will be posted, the recording of this video will be posted by tonight at the most, but the handout will be ready in the next half an hour to 40 minutes. Okay, thank you all. You all have a wonderful day. Bye. Thanks, Hemant. Thank you, Teja. Thank you, everyone. Thanks, Gautam, Hemant, Murali, everyone. Thank you all.